Hey math kids, we're going to talk about 3-point EA, and in this video we're going to graph a function with and without technology. We're going to create a context that would explain the path that it's taking. We're going to find a maxima and a minima and the x-intercepts, and then we're going to describe what those would mean in the context of whatever context we come up with. So we're going to start with this function, and so let's do a new window. We're going to go to Desmos to graph. And first I'm going to graph this with technology, but I'm also going to show you how to graph the same one without technology. Okay, so we got this graph. Bring it over here. Let's see, we'll do this. Okay. Actually, I'm going to make this window a little bit smaller so we can look at it at the same time, maybe. Not quite. Let's do it that way. There we go. Okay, so here's the equation. Here's the graph. So I'm just going to sketch this graph, making note of a few things. So the first x-intercept is 1.261. So x-intercept, let's do this. So we have x-intercept, and I already forgot what that was. So we have 1.261. We also have another one at 6.739. And then we also want our maxima, which in this case it's a maxima because it goes up and then comes back down. And that is happening at 4, 5. Okay, so these are all x values. Now these are going to help me sketch my graph. So I'm going like this. This is my 6.7. This is my 1.3. So those two. And then this value right here is 4, and then this y value up here would be 5. Alright, so I have my graph, I have my x and y intercepts. Now we just have to come up with a context. And I think what I would say in this case is right here is the top of a building. So what you might consider the ground is the top of a building. And so we are standing at the bottom of the building, and we throw a ball over, and it comes back down, and then we're going to think of this like our ground. So our x-intercepts in this context are going to be when the ball is level with the top of the building. So this is when ball is level with top of building, of the building. Okay. The maxima is going to tell us when when the ball is at its highest point. And I think we covered everything we needed to in this problem. So the only other thing I want to do is I want to show you how to graph this by hand, because you're asked to do half of them by hand and half of them with a graphing utility. So I'm just going to take this same function and graph it by hand. So what I'm going to do is I'm going to first graph the vertex, which the vertex is going to be 4, 5. which we see on this one. Let's see, how should I do this? I'll do it up here. Okay, so we have our graph. So we got our vertex, so we're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Then we need to know our y-intercept. So we're going to plug in a 0 for x. So we get negative 2/3, negative 4 squared plus 5. Negative 4 squared is going to be 16. And I'm going to rely on a calculator from here on out because it's just easier. So I'm going to say negative 2/3 times, what do we have? 16 plus 5. And that's negative 5.66666, repeating. So 1, 2, 3, 4, 5, 6. So it's going to be about here. This is like my middle point. So I'm going to have to move over here a little bit. And since I'm 1, 2, 3, 4 away, I got to go 1, 2, 3, 4 away. And then down on the same y value. And my graph is going to look like this. Now, my scale is a little bit different, like this is a little more spread out, but these really are the same. It's not perfect, but see how this is 1.3. This looks more like it's at 2, but that's just because my drawing's bad. This is about 6.7 or 7, and this is 1, 2, 3, 4, 5, 6, 7. See how that one's pretty close to 7, like 6.7. So it is the same graph. One's a little more precise than the other one. If you need additional help, please come to Math Lab. Until then, calculator.